Okay, hello, welcome. So my name is Alexis Comte. I'm senior manager at Nova Space, which is a leading consulting and market intelligence firm dedicated to the satellite sector. So thank you for joining us today for this new webinar in this GOSA webinar series. Today's webinar is supported by in partnership with Proactive International PR, which is a technology public relations agency combining B2B digital marketing, market insights, and computer analysis. So today's topic is to deal with the Earth observation that is at the turning point, and to better understand who benefits, who leads, and what comes next. So let me first introduce the panelists of today. We have a great lineup of people with first-hand experience on the topic. We have Dr. Minda Sushan at MDA, Alessandro Flamini at EGEOS. We have Sarah Kesnov at Airbus, and last but not least, Florian Dekonik at Open Cosmos. So we'll start a little bit with the context, and then we'll go directly to the Q&A and have the opportunity to hear more from our speakers. So please let me share with you two slides about the context extracted from our free extract market intelligence flagship report. This report will look at the downstream of the Earth observation value chain, which means the commercial data and services, which stood at 5.3 billion in 2024. And about the trends and the context, I could say that there is a growing data demand supported by growing interest from premium datasets and higher visit rates. But on the services side, this implies a growing demand from pixel to intelligence, and customers are expecting to get the right answer at the right time. So we are at a turning point from constellations to interoperability, and we're gonna to build hybrid space architectures, and yet customers now demand greater operational awareness, refusing trade-offs between premium resolution and high-res datasets. And this makes the Earth observation evolving into the information domain, integrating multiple networks, platform payloads, and creating as well standardized process and facing defense and civilian architectures within a resilient orchestration of dual-use capabilities. The key challenge, but I'm really looking forward to hear more from our speakers, is as no single company can address all these dimensions, the industry is pursuing strategic vertical integration and or key partnerships to fill the gap across the value chain. So with question one, I will let the opportunity to our panelists to quickly introduce themselves, their company, and the latest achievements as well. We will talk about the demand evolution, and as said, as we are witnessing a fundamental shift, a return to core principles with defense, dual use, and related security applications. How does this shift impact your current business, if at all? So we'll probably start with Dr. Minda Sushan, if she's the first on the list. That will be a great pleasure to hear from you.
Well, thank you so much, Alexis. I really appreciate the opportunity to participate in this panel, and it's exciting to talk about Earth observation. I think there's a lot of different dynamics going on, as you mentioned in your past two slides, and there's just more and more emphasis, I think, on dual use and how you move forward. So my name is Dr. Minda Suhan. I am with MDA Space. I am the Vice President of Geointelligence. We are focused on both Earth observation and space observation. In Earth observation, we have a long history with radar imaging satellites. And so this is something that we are find a lot of different use cases for and continue to evolve. We built RadarSat 1 back in 1995. RadarSat 2 is still operational today. all the way through. And now we're excited to be building and launching at the end of the year our next generation radar satellite imaging system called Chorus. So dual use has always been such an important part of our business plan. We've always been serving the Canadian government and recognize that defense and security will always be and continue to be a strong customer for Earth observation data. And though sometimes their missions are slightly different than the other missions and other end use cases, usually in terms of the timescales and the need of the data, we certainly recognize that this will continue to remain strong. And there are always times, especially in the dynamics of the geopolitical world today, in which sometimes the defense and security bumps up and becomes a higher priority at times. And we always are going to step up and address that. But I think that the end use cases outside of defense and security will also continue to grow. And I'm excited to talk more about that as the panel goes on.
Thank you, Minda. I will let the floor to Alessandro, if it's okay.
Yes, thank you. It's a pleasure to be here. I really thank you for the invitation and to host this webinar on this really relevant topic for all of us. I'm Alessandro Flamini. I'm the head of Defense and Intelligence Sales Department, managing also Cosmos SkyMed. As you know, we are in IGEOS. We manage at worldwide level the rights to resell Cosmos SkyMed, and Cosmos SkyMed constellation is built on the first generation and now the second generation. And we are natively dual use. In fact, we have managed, starting from the beginning, the Cosmos constellation, and he has always operated in both civilian and dual use domains. And in this geopolitical context, there is a clear market shift back to security, and it is directly connected to our business. And users now expect to be fast, scalable, with the high quality of geospatial intelligence in terms of data, but for sure also in terms of solution. So IGEOS is able, thanks to the data, to access to the data, but also to our solution that we have developed a long time ago, and now we have integrated with the AI machine learning, so with the new technology, AI performance computing, to provide user-driven solution powered by rapid tasking, source agnostic. So we know very well our main basis, that is Cosmos, but in this domain, in this context, we need to be fast, and we need to have all the access of all the data. So we are a solution that is agnostic, and we provide an end-to-end service to acquire information. So we acquire and with the sensing of the satellite data, but we transform this data into information, actionable, with high quality, a very rapidly solution to our end user. We have an expanding of our role as trusted provider of solution, of sovereignty solution, ready to be geospatial information. So translate from pixel to information.
Thank you very much. And Sarah?
Yeah, so again, I will thank everyone and Joshua for the opportunity to be part of this panel. So I'm Sarah Casanova. I'm the head of portfolio and performance in a division of Airbus Defence and Space called Space Digital. So in Space Digital, we do a lot of different type of activity, including geospatial, but not limited to it. We also perform a lot of development and operation in the exciting domain of satellite-based connectivity, but also then the geospatial part that I'm representing here today. So as for the question you just asked us, I think the shift that you're mentioning is not the fundamental change for Airbus. We have been for more than 40 years operating assets in both optical and radar that are by nature dual use, and are operating also by nature under the rules and the law of the countries that we operate in, be it France or Germany or others. We have been serving for all that period of time a large number of defense and intelligence customers And the services that we deliver, they're structured for those users as well, with the right SLAs, the right priorities, the right tasking rights for those users. However, what we can see more recently is obviously, as probably all of the colleagues here on the call, an increased demand due to some very complex geopolitical situation that triggers a demand in intelligence, which is quite right. And sometimes that pushes our systems to their exploitation limits. And it's a good and a bad problem at the same time, but this is also a reality. And that's why, I mean, for us, it's quite exciting to look forward and to consider that we'll be launching new assets with PNEO Next 2 in 2028. So that's going to bring us more capability. But we also see another trend that was not yet mentioned, which I think is around the fact that the data we generate have to be trusted. So when we deliver something to our customers, they have to trust that what we're delivering is not some weirdly produced deep fake from somewhere. And that's an area where I think there's a lot to do, and we're certainly Nervous are doing a lot to provide that extra layer of not only providing a pixel or an information, but a trusted one.
Especially in the context. We will depend a little bit in question 3, for instance, but let's move on with Florian. I'm sure you will bring a new picture of this market evolution.
Yeah, and thank you. Very glad to be here. I hope you can hear me well. So exciting because Open Cosmos actually is relatively new in space. We were created more than 10 years ago. 10 years ago, last year we celebrated our 10th anniversary. And for us, effectively, there has been a lot of change. So nearly every year was exciting. But I will go as far as saying that 2026 will be definitely much more exciting than all previous years. And contrary to what happens sometimes, I wouldn't be able to say the same for all the past years. The big change for us actually that we have experienced is also what we think is coming along today, which is that so we started effectively, we were in one country. When I joined the company 7 years ago, there were only 25 employees. Now we are 250 employees. We are a pan-European company, so across the UK, Spain, Portugal, and Greece. And we design, build, launch, and operate satellites. But we also try to bring the entirety of it. So we also distribute the data and allow others to effectively derive analytics or information from it. And most recently, we actually announced that we were also moving towards telecommunications on top of our Earth observations that we're doing. We effectively started with a lot of precursors that were demonstrating a lot of, let's say, innovation using small satellites. So starting with CubeSat, but the majority of satellites that we'll be launching over the next 2 years, actually 50 of them, will be all of them actually micro satellites. So we are definitely moving in terms of size. And what we see definitely going forward for us and for the industry is going from a time of testing to really operating. So operationalizing whatever innovation was tried before. And we need to move from a priority on innovation to industrialization. It's not negating innovation, but it's changing the course or the focus that we have with a system approach in mind and focusing on the end user.
Great, thank you. So if I'm understanding well, for legacy player, this is not really a big change as you were already positioned in the dual use, let's say, business, but the way you are doing it probably gonna to move very quickly. That also explain why new providers such as Open Cosmos appeared. So I would like to ask you the question too about the drivers, challenges, and market growth potential over the next 10 years. So as we're gonna have to move forward to complex system architectures, this is probably the way you are doing it, the way you are addressing, dual use, which means you have to secure your network, to make it interoperable between defense and civilians as well. And looking at the architectures is from the pixel collections to the information delivery and its dissemination. So it's all along the value chain. I will not too much anticipate to the question 3, which is about meta operators. But I would like to ask you for the drivers challenge and market growth a little. I would propose you to have much more technology or approach or focus much more on the regulation or data access to discuss a little bit about how can Earth observation, for instance, and telecom satellite can work together more effectively, creating interoperability, bridging domains, and how to use as well generative AI to deliver actionable intelligence, and how to use quantum tech to deliver it in a secure way. So we saw recent move from companies having quantum tech parts of their technology right now, securing the information domain as well. So could you please tell us more about this? Who wants to go first? Yeah, fine.
Please, Alessandro.
Yes, sir. Be free.
Okay, so from our side, the way we looked at it, let's say more on a macro evolution, is that the value of growth will come from timing. So one of the experience that we can see is that GNSS effectively solves that problem because you can have it nearly instantly. It's similar for telecommunication. For Earth observations, there was always a problem that you can't access live information from satellite imagery with your phone. That's to put it simply, except maybe weather forecast. And that's really what is driving, what we see a lot of the drive for this, combined with, let's say, two trends. The first one is that our world is at stress for multiple reasons, but geopolitically, defense, we can see it, it's an obvious one. In terms of energy, in terms of climate, when you are at stress, you want to refresh your image as often as you can. Even biologically, that's what everyone does when you are stressed, you blink rate increases, for example. And that's what we see also government doing a lot. That's why a lot of them are effectively pushing to have more information faster so that they can update their understanding of the situation and adapt because stress is increasing on all fronts. Concurrently with this, you have another trend that we saw a lot on our side, which is that the minimum cost of access to Earth observation, or minimum operational capability for Earth observation has decreased to the level that now more nations are able to have their own system. And you can see this through a lot of emerging space nations, a number of space agencies which have been created over the past years. And that's really what we see as driving the growth, and actually exemplified also in your graph, which was showing roughly 75% of it would come from government. Within this paradigm, so telecommunication plays actually two roles. It's effectively the first one is there is telecommunication for people, but you also have telecommunication for our own satellites. And although there have been trials in the past, this has never been really put at a level of full operational ability so that you can have near or real-time information from space.
If I may just go right after. So I think what you're just building upon is the concept of space data relay, which has been existing for quite a long time. I mean, the EDRS satellites were just an example of that type of capability, right? Beaming Earth observation data back to Earth using RF links. I think what we have seen in the telecom domain, which is also something we cover in Space Digital, is the emergence of the low Earth orbit constellations, some of them equipped with a lot of inter-satellite links that are actually very interesting in terms of the capability they bring for governmental and sovereign users, but not only, in terms of having your data transited through a secure and controlled pipe of data. And in terms of evolution, at least what we see Nervous and also when exchanging with our customers is how do you leverage the power of those low Earth orbit constellation or MEO type of constellation, or even GEO in certain instances, to be acting in as a backbone to transfer the data from our Earth observation satellites. And for me today, the real issue is not the technological evolution, because the technology is already here. I mean, this is already what we do every day on the constellation of low Earth orbit satellites like Starlink, for example, or what will happen with Amazon Leo or the next generation of Eutelsat OneWeb. What really needs to happen is the automatic equipment of the Earth observation satellite with the necessary laser capability to connect to those assets that are already existing. And the product is here. The terminal, the laser terminal, I mean, TSAT is building it very well. And now it's just a matter of getting in there and creating the end-to-end offer and the end-to-end solution for the customers.
I absolutely agree with both you, Florian, and you, Sarah, in terms of really the technology is there, but the nature of the space and building Earth observation satellites still takes a certain amount of time. And so making sure that you have that tech that is available to insert and be able to take advantage of that transport layer that communication satellites brings to the table is absolutely critical. I think additionally, when I think about how communication satellites and SATCOM is moving forward these days, and if I think a little bit further back on the value chain in terms of actually manufacturing of satellites, and I find that the constellations today on the communication side tend to be in the hundreds, right? As opposed to the Earth observation satellites, which have their own technology and their own production time, which can take, and then are certainly fairly complex, that just adds more time to the production. And so what we're trying to do in MDA Space is to really try to take advantage, not only in the ways that downstream and that Sarah and Florian talked a little bit about. We're also trying to take advantage of the high volume manufacturing and production of satellites early on as well. And so communication satellites, as they become more and more digitized, we think there's a lot of opportunity to bring forward that same kind of cost efficiency and that high volume manufacturing and take advantage of that so that we can start building up in a very cost-effective way the Earth observation constellations as well. And that then goes into the conversation of constellations and systems of systems, that we really think that the entire ecosystem of space and communication and Earth observation is really pivoting more towards. So I like not only on the back end of making sure that we have the technology to take advantage of those transport layers, but also the production and manufacturing capability and being able to bring those cost efficiencies from the communication satellite systems into Earth observation.
So I believe that I can summarize the interview of all the Minda, Florian, and Sarah, because it's clear we are moving towards a system of system and federated architecture. So Earth observation, telecommunication, i.e. all the new space technology are converging. So the opportunity is to turn this complexity, because it's complex, but into operational value. So what we can do first is to have a working EO with telecom satellite, to have together real-time transport, persistent connectivity, distributed sensing. So in this way, we can guarantee much faster tasking, downlink, delivery. So especially for defense, security, and crisis response and mobility domains is really relevant. So we can support our end user, our stakeholder with a trustable system, but also timely, that can guarantee and can be used for their purposes. Second, there is the AI. So it's clear that we have a huge amount of raw imagery. Now we need to transfer and to use the technology to be able to transfer, to translate this raw imagery into actionable insight. And the AI could help us to do this. And delivering from pixel to patterns, to understanding and fusion SAR satellite data, optical satellite data, IS, RF, so AO and non-AO data into insight. And this is really important for all the companies that are managing and supporting the space ecosystem. So this emerging technology will accelerate the transformation. Is here, as all of you have clearly stated, and we are, all of us, integrating in our workflow, in our value chain. But for example, the onboard processing will be the present, is the present, but will be for sure the future, to shorten the chain, to be again more faster, and to support all the requests that we receive, and to satisfy all the user requirement in terms of timely, trustable information.
That's really interesting because what I've heard is that Earth observation has to adapt to the telecom rather than the telecom to the EO. So is it because EO is a smaller market, or is it because it's probably the natural way to do it because of technology and so on and so forth? What is interesting as well from what was just said is that the natural evolution of the business is toward consolidation. So no one can do everything along the value chain from we are talking about orchestrating systems of systems, right? So from the ability to task multiple payload, multiple systems, multiple ownerships, to capture or downlink this information timely and responsively toward a secured stream, and as well to process them efficiently with the right tools to solve the questions and to deliver and disseminate this information. Each word is a key part of the value chain in Earth observation, and from end-to-end services, no one can do all of the things because, as you mentioned, it do requires HPC, do requires being cloud computer, cloud compute, I mean, a provider of cloud computing. It do requires as well the capability to build AI efficiently and to adapt this AI to different sensors, payload network, etc. So I do see that there is a path for more integration. I do see there is different strategies from the original, let's say, footprint of respective companies. But as no one can do everything, what do you see as the best fit and strategy, and on which part of the business do you think it's the best way to start consolidating or developing such integration to fill the gap along the value chain and to better serve emerging needs securely, efficiently, and competitively?
I think I'll jump in here and just say, listen, everyone on this table, on this panel, we all interact with each other because we recognize that Earth observation, especially, I think, lends itself to strategic partnerships, conversations. Sometimes we compete, sometimes we partner, and we recognize that we bring, just by the nature of Earth observation satellites and the complexity of it, and the fact that no one satellite can solve all the problems, to Alexandro's point, the consolidation and bringing together of all that data in order to better serve our customers continues to drive the Earth observation industry. And so I'm always balancing things on the strategy side between strategic partnerships, between is this competitive, is this where we can go and team with others, and certainly there's always that balance going into the different opportunities. And I think not only is it about the different capabilities you bring to the table, but the different markets that you might address or the different customer missions that you might be addressing. And all of a sudden, perhaps there's a customer out there that we don't necessarily serve directly, but Airbus does a really great job. And so we want to make sure that we provide additional capability to help them be successful. Because I think, again, in the ecosystem of all of Earth observation, it's so important to be able to leverage across the value chain. And to your point, Alexis, no one company can solve it all. We can maybe do it in a very small slice, but it's still not necessarily meeting the full end user or the full mission need of customers.
I think what Minda just said, some of the customers are actually asking for us to take on that responsibility, because for a variety of reasons, but they may have not enough experts to be able to manage multiple contracts, not enough time to do this, or they simply want all of their data to be treated in the same way, as in processed in the same way, so that they can be comparable to one another. Because today, the way we manage our radar data and the algorithms that we use are probably not the same, the one MDA Space is using. Then how do you compare apple with apple and peers with peers if you're not doing it in that way? And that's, I think, is the concept of meta operator that you've mentioned several times, Alexis, which is a concept well known in the space industry, and it's been existing in the SATCOM domain for over 25 years. So we know roughly how this is done. And I think there's some key challenges that need to be solved within the geospatial domain to really get to that level. So all of the digital platforms and stuff like this will manage, because this has already been done in SATCOM. But there's some very specific things, such as standardized API, standardized format for the image generation, or even standardized way of tasking our satellites that are completely different to one another, and they will require the industry to start working together in order to make it happen. But I think it's already started, so I'm quite confident we'll get there.
I totally agree with Sarah, because it's really started. We have the example, for example, in Europe with ESA, with the RRD, Rapid Response Desk. This is a platform with common API, with interface. So it's allow and support the Copernicus program and all the services. But also thanks to our European institution, for sure there is this push to evolve in this direction. And again, we have the design of OGS that is in this direction again, or with the ARS. The architecture is and the competition will be complex, but we need, as said also by Minda, to have this strategic partnership, because the real opportunity to evolve in a meta operator means to have an orchestrating system, multi-sensor constellation. That means I have seen there is a question and answer, the question on band X, CL, how the SAR can work. This is something that will be helpful, all the sensor, to support and to translate, I have said several times, data into information. Why? Because we have several acquisition timing, several band that will support by different point of view, with different time, to work on the requirement and to give the right support to the end user. So the opportunity is to have a virtual constellation, let me say, is now really abused as in terms of definition, but is the reality, is having something that will allow to increase the capability of all of us to answer and to cooperate with the federation, to give the support to the end user, because at the end, as I said before, they need a faster information. So the challenge for sure is the standardization. So common API interface, data model will allow to use this constellation and to be interoperable, so in secure way. But the winning strategies is to lead this orchestration, is to secure data, API, pipelines. And in this case, if we have also between the companies, but also at institutional level, for sure a sovereign satellite as a service provision. And we can ensure to our end user a reliable operational intelligence. And the trend in Europe, at the end, we can see also the M&A activities, is to federate, is to cooperate more between the companies. And for sure, this is also now well known in Europe, that have several different latitude process in this sense.
Thank you, Alison.
Yeah, it's a very similar views. Even though we're a smaller company, we arrive at the same conclusion in terms of, let's say, the ideal of the end-to-end service. The key blocker every time, so at least we saw facing in space, is that it's a very intense, capital-intensive effort, and which requires several customers usually to justify it, or a very large one, which is why it naturally moved towards defense. Although now we should say a lot of different governments are starting to go towards this side on the defense one. And consolidation is inevitable for several reasons. The first one is they need operational systems, so they don't want to have to deal with 3 or 5 different ones. And the same actually as one of the worries that happened for GPS. There were a lot of competing systems, like initially Transit, LORAN, and Omega, and at the end only one survives, the space one. But there were definitely big decisions to be made there. And space is still extremely complex, meaning that we cannot still find today one entity that will be able to do everything as a system of system for multiple reasons. And the interesting part, let's say, at least in Europe, from what we've seen, is there have been a lot of support over the past 2, 3 years, which is now finishing, which has created a lot of new companies, as well as so both government but also private investments. But now this is running out, but a new one is coming, which is more coming from so civil and defense, and which is asking for something different. Before you had to try things, now you have to deliver things reliably. And within this, effectively, out of all these different new initiatives are good ideas that will start to be picked up, or so-called as acquired. As ourselves, we even acquired 2 companies over the past 2, 3 years. And that's what we're going to see emerging, because whatever has not worked will effectively either die or be acquired and selected. And what will really make a difference will be the ones who are able to simplify whatever they are offering to the client.
Thank you. I have probably questions that arise in my mind, but I will keep it as kind of optional one at the very end. It's about centric aperture radar becoming, the probably the backbone of new system. But let's move on to question 4 with new businesses and what's next. What will change or what will remain the same regarding your end use case or end use cases? We talk about different things, but we didn't had the opportunity to deal with SSA and the synergy with the Earth observation, or to talk more about the opportunities of the satellite as a service, which is as well, Sarah, a very old one from a legacy perspective, but more and more satellite operators are engaging into this domain as well, such as ISI, for instance. So I want to know more a little bit of how this new, technical capabilities as well opens new market opportunities, even closely in close relation with data and services in EO, and sometimes moving to satellite as a service and or SSA. And yeah, so that would be my first question. The other one would be about what kind of applications related to security and defense, as defense is going to lead a new innovation cycle, are gonna to open, because they are probably based on the same requirements. Is it from greenhouse gases, because multiple sensors can solve the complex issues for, I don't know, as well, storage emissions? Or is it about coming back to civilian legacy ones, such as crop or forestry? Or is it much more gonna to open security related applications, such as maritime domain awareness or even disaster management? So the answer is so first, what would be new synergies between EO and SSA or satellite as a service, because we didn't have the opportunity to deal with yet.
So I can start on this one because it's something, at least from our side and from the people experience in the company we have, is not an intended use, but an added use of Earth observation satellites that we started to see, let's say, 3-4 years ago, which is instead of looking down at on Earth, so 70% of the time at least you have water, and even the rest of the time you don't have that much to see. Is why don't you use your satellite to try to take pictures of other satellites or try to see some trails on your sensors? So there are definitely uses for this. After whether or how compatible it is with the Earth observation part is still to be explored. But it's definitely growing since the past years we've seen this, although not that big a market yet. But actually, I'm quite keen to learn from others on this one.
So I would also say that there's a lot of synergies around that when you think about how to understand, because as we all know, the satellites and the complexity and the build on Earth are an Earth observation. Certainly, there's a lot of valuable assets in space, and so when you think about servicing satellites, it becomes really important to try to continue to extend the lifetime of satellites. And the opportunity to do so, well, it was always a challenge, decades ago, because once you launched, you couldn't really do much more, and you were kind of at the behest of how the satellite was built and designed, and it could, hopefully continues to operate. But with the kind of services that could become available in orbit, I think there's a lot of compelling opportunities there that not only to look and use satellites to watch other assets. The focal plane might be the focal length might be slightly off, but be an opportunity there. But also then to be able to say, can we put things in space that could help, for example, with the deorbiting conversation? We have more and more satellites that are being launched, especially on the SATCOM side. Is there a way that in-orbit servicing could potentially help with the deorbiting requirements and being able to to make sure, because we all get nervous as we operate assets in space, that we do not want uncontrollable objects in space, and it's getting more and more crowded. How do we declutter? So I think those kinds of technologies and evolutions coming online is also very important. I would also say that further downstream on the data and services side, some of the ecosystem and the lessons that we've learned on the analytics side not only apply with Earth observation data, but also with space situational awareness data as well, where you need multiple types of data and fuse that data into a more comprehensive information package so that people can make decisions on, and feeding that back to the appropriate either operators who need to know that information in order to protect their assets, all the way through to just understanding if you want to put a new asset into orbit, where best to place it. So I think all that is very much an ecosystem that feeds back into each other. But I am excited about some of the newer technology and ideas that people are talking about for the in-service support as well.
Great.
I think, Minda, what's quite interesting is the vision that we have in Airbus is that we are today kind of best in class for looking down, from Earth, from space to Earth. And actually, nothing really stops us now from doing it the other way around, like breaking up from space to space, which we started doing with some precursor satellites. So you might have heard of SOAP, which is an SST. So we're doing tracking rather than imaging. So we're following points, effectively, ephemeris. It's a demonstrator that was launched recently and that we are operating today as a service. And the demonstration of the results that we can obtain and also the types of service that we can deliver to end customers, especially defense one, our intelligent one is really interesting, because there's today a big void in space. So there's loads of things that are happening out there. But for our customers or defense forces or even for the operators, it's sometimes really hard to kind of identify assets, to attribute them. Attribution is a nightmare. And to also have that, constant surveillance of checking what's happening. So there are things that we would like to be doing in that area for sure in Airbus, and this is an investment area. I think it would be integrated later down the line within this overall ecosystem of data and services that can be delivered.
Yes, my comment on the SSA and the O is that for sure the space become congested. So there is a lot of satellite operational, but also debris. And we can observe for sure, as EGEOS, we are a geospatial company. So as the Airbus colleagues, we translate from data into information, so from the space to the Earth. But there is also a lot of techniques also from the Earth to observe and to trace and to monitoring. So with the sort of training the satellite. So this is something that is already done. That is for sure we need to integrate this information, combining observation, the taking with the analytics to be essential also for commercial operators. So to expand the role from monitoring only the Earth to monitoring the full environment. So not only what is the main requirement that is giving information to our customer to observe the Earth for space defense or for B2B sector, but also to support, because at the end we monitor from the space infrastructure, but space is one critical, probably the main critical infrastructure. So we need to protect it, because otherwise we will have not the support that we are proving now, that we are allowing also to develop new market, new technique, new solution to the nominal market, that is security and defense or emergency, but also to something that we can develop with oil and gas, with trading commodities, with energy on the Earth. But one customer could be also the space because need to be protected.
Fine. Would you like to add some words, Florian?
If I may, to conclude, from the space to the Earth is my I would like to leave you with the evolution that technology evolution we can bring to our customer is to move from static snapshots, so from images, to continuous predictive system. So what we can do is to support, and Earth observation will be one of the most relevant layer in the digital twin. So combining the information with the high performance computing, AI, but we can support the modelist to understand better the Earth, to understand all the physical model, so could be applicable for flood monitoring, so to be predictive, to study the return period. So we have not only one image in a specific time. The real value of the Earth observation is also the monitoring. So we have a lot of data in the past. We could have, and thanks also to the new constellation with new space, a lot of hyperspectral images. So a lot of more different data, the topic that we have mentioned before. So with the federation, with the multi-sensor activities, we can bring a real value to increase the quality of the model on the specific digital twin. And for sure, the goal could be also in the future the digital twin for defense. So having something that can predict the status of what we are observing now, as with the date, with the timing, but later on we can integrate within this digital twin model that will support the decision maker to have a clear picture of what would happen if it is the case with the different what if scenario. So for me, it's really important to support the academia, the institution, in private investment in this direction, because we'll support in the future new market, but also new type of information that we can bring to the end user that is actually our main customer.
We could probably try to move forward to the Q&A from the audience and keep a short time to try to answer them. We'll start with an anonymous attendees that's posted a question. That is a little bit that you should be able to see right now. And it's a little bit in resonance with the questions I've had for you. So what's next? What kind of, let me rephrase this way. What kind of civilian applications are going to benefit the most from this new, set of architecture?
Oh, go ahead.
Go ahead. Please. No. I have a speaker up. Please.
Okay. So in terms of civilian applications, I think there's always going to be, in the dual use conversation that we've been having, additional end use cases, especially as the technologies evolve. And so what I'm finding is that defense and intel, even though they are certainly driving a lot of my customer needs and kind of the help push certain technology, especially as latency and everything like that comes into play, and the cyber, this trusted source is also very key all the way through. On the civilian side, what I find is the technology like artificial intelligence and the ways that you can articulate and pull out the information value from the satellite data becomes more and more important. Because on the civilian side, you're probably not going to find as many true SAR experts or radar imaging experts or optical imaging experts. And so the way to automatically extract that information through the newer technologies that are evolving like AI, I think will continue to enhance the civilian applications going forward. And I think of things like, for example, I was recently at a conference with NASA, and they had their folks from the banking industry there, where they are saying, hey, it'd be really helpful just to know, what ships are correlated with certain RF frequencies, and not necessarily need to see the satellite image itself, but the information that can feed into a risk estimator for either insurance companies or finance and banking companies or chain of custody civilian kinds of applications. So I see more civilian applications evolving and growing as the value to extract that from the information to be extracted from satellite imaging, it becomes easier and easier.
Look forward pursuing this conversation because, the business model of the data point should not be the same for defense or finance, but at the end, it's really interesting now to try to bridge these different communities with let's say single stream flow. Let's have a new question. This one for Sarah. So can you please characterize to what extent is the industry relying more on AI to process EO imagery? And is the use of that AI contributing to fear of deep fakes, as you mentioned?
That's an interesting question. So is the industry relying more on AI today to produce the data? I'm going to say yes or no. Yes and no. This is both a question. So we have been using LLMs, so that type of AI, not the Gen AI that does everything, or the fundamental models that you can see, Mistral or Google or ChatGPT, but we have been using AI data management for quite some times already, right? What we're investigating now today is the use of more automated large language model type of AI application to talk to our images. So this is something we've been doing in Airbus for over 2 years now, where we have basically trained those models on our data sets, which is, I mean, we have a lot of data, obviously, in all of our archives, and we use it as a way to test whether this is something that can be used to maximize the value and the usage that we can make out of our archive data. So this is a project called Sherpa, and effectively it works very well. You can talk to your image, talk to your system, and ask it to do a lot of things, like find me all the places on Earth that look like a heart, or in that area, I want to understand where all the tennis places, or how many cars are in that area. So that's the type of use cases that we're investigating. Now, it's not today fully incorporated into our production chains. And one of the reasons it is not is because we need to work with the acceptability for our end users to have data that have been processed in one way, shape, or form using artificial intelligence. Now, some of our users super on board. Google is one of the biggest customers that we have on the commercial domain, and obviously they see a lot of added value in that. Our defense customers are a bit more reluctant, because at the end of the day, it's all dependent on the use case. When you use an Earth observation data to conduct a sensitive military mission where lives are at stake, you may be a bit more reluctant to use AI at the back of your data treatment. So for us, it's all about working hand in hand with those customers to see how we can serve them better using that technology, but at the same time experimenting in a fast mode with the big players like Google's or others, in order to see what we really can do with that technology, which is quite interesting in all fairness.
Alessandro, I see you moving a little bit, try to probably jump on.
No.
You have the opportunity for the last word.
I totally agree with Sarah and Minda that there is for sure the opportunity to have a new market, and the new market for me is as sales. What we see that is for sure finance could be really interesting, and there is a request. Okay, the oil and gas is already our end user, but also the training, the commodities, the real estate are really, and the mobility are really something that as Earth observation we can serve, we can provide information to help. You can imagine that also having in mind the digital twin, that we can also support with our acquisition, integrating and federating all the information that from the space, I don't want to speak only of images, can derive, that we can support also cities, so the management of the street in order to avoid any issue with pollution or whatever. So to suggest to have a different view, and you can integrate this with information from GPS, GNSS, and so can support also the citizen to be helpful, to have a good trip from the start to the end of this trip, but also to support the city to avoid any issue with pollution. So it's something that is real, is now, and we can provide support. And there is also a question of if we see only, and I believe that I can answer for me and Sarah at least, but also for the Minda. We are not only data provider. We are just spatial company. We have the access to data, but we have also end-to-end solution. So algorithms, tool, platform that support the end user. It's something that is already now, and we use day by day in the day-by-day activities. Sorry.
Open Cosmos.
Yeah, thanks, Ryan. We are running out of time. Probably we'll require you to probably Florian have the very final word, if you don't mind, and then we propose to close. Yeah.
and joining actually Open Cosmos to the list because that's really what we're trying, I think, all jointly to do is simplify access to what space can bring. And specifically, actually, I completely agree with the most demand we've seen growing over the past 2 years on the civilian side is finance, specifically insurance and reinsurance. And we've seen this because back to actually the analogy I was using initially, what is at stress wants to be monitored very often. And that's what we see coming.
Really interesting. Thank you very much. Okay, so I propose to close this very insightful session. If there is any questions we didn't have time to answer during the live program, please do not hesitate to address them in rating and to post them alongside the video on the GOSA website. I kindly recall the gosa.com is the website on which you can have the records available and you can have the replay for free. So please do not hesitate. Again, a big thanks for the panelists today. A big thank for the sponsor, Proactive International PR, for bringing us together, and as well as GSOA for organizing this great webinar series, and to the audience for your questions. So I hope this was an insightful session. I was very happy that so many of you joined today, and I wish you a great day as well, or a great evening, and hope to see you soon again. Thank you very much. Bye-bye.